In a molten oil drop experiment, a particular oil drop weighs 2.4 times 10 power negative 14 Newton. The parallel plates are separated by a distance of 1.2 centimeter. When the potential difference between the plates is 450 volts, the drop is suspended. If the upper plate is positive, how many excess electrons are on the oil drop? So, as soon as you see that the oil drop weights, we know that's due to gravity. And this is the force 2.4 times 10 power negative 14, which equals F equal mg not A, because it's due to gravity. So it would be Fg, and this would be G not A. So this is the force due to gravity. And the parallel plates are suspended by a distance of 1.2 centimeter. We would convert this into an SI unit, which would be 0.012 meters. When the potential difference between the plates is 440 volts, the top is suspended. If the upper plate is positive, how many excess electrons are on the oil drop? And we're calculating the excess electrons. So first of all, you would going to draw the diagram. And this is the equation for finding the excess electron. So we will draw the diagram. It doesn't need to be as neat as this. It just needs to be like a rough diagram so you can see what is going on. So we know that the upper plate is positive charge and the negative plate, as it says in here, where is it? If the upper plate is positively charged, and we know the other plate or the down plate would be negatively charged. And we know that the force in oil drop, molten oil drop, is it's the charge force and the gravitational force. They gave us the gravitational force. They didn't give us the charge force because we're going to find the excess electron, so we need to find Q. So we know that, as you can see from the both arrows, is equal to each other, and we know that both forces are equal, so that's why the electron or the particle itself is not either going up or down. So we know that the force of the charge and the force of gravity are equal. So that's why I did QE equal mg. And then QE equal mg because we're going to find Q to find the excess of electron, because we know E is a constant. E is 1.6 times 10 power of negative 19, or you can say 1.602 times 10 power of negative 19. So get rid of the E to leave us with this equation. We know mg, which is the same as force as it gives us in here, 2.4 times 10 power. So we have this number. We're going to find E. Easy as this. We have an equation that says E equal change in volts divided by distance. So change in volts, we have it in here. The distance we will convert it to an SI unit, just dividing by 100, which will give us 0.012 meters. And the answer would be 37,500 Newton per coulombs. And then it's just the same as this equation, which we did in here. We would divide the force that we have in here by the E, the electric field force, which we got from here, which would give us 6.4 times 10 power of negative 19. And then we're going to find the excess of electrons as we have the Q. Easy as this, we found the Q. So what we're going to do is rearrange in this equation for excess number of electrons, and then you will get 6.4 times 10 power of negative 19, which we got from here, divided by 1.602 times 10 power of negative 19, which is the constant, which would give us, in the calculator it will give you 3.99, which is incorrect because electrons can't be like water, like it has decimals, because we can't get a half of electron. That doesn't make any sense. So we would get n equal 4 because we want it as an integer, not as a decimal. So that's it. It's a really easy question.